Last week we focused on the concept of solubility and concentration, and this week we are going to calculate concentration based on the amount of solute in a solution compared to its amount of solvent, or the liquid. So we're going to use this ratio of amount of stuff dissolved to the actual dissolving liquid to figure out a measurement called molarity, and molarity is our calculation of concentration. So molarity, we want to write that here. This is our measurement of concentration so that we can actually quantify the amount of solute in solvent. And the way that we actually calculate solubility in terms of molarity is to divide the amount by the moles. So when we talk about molarity, usually we will use a capital M to represent molarity, and then amount over volume. We've seen N and V before. So there's our little equation. Molarity equals amount over volume. So again, capital M is molarity, and it has units of moles per liter. So that's telling us now what has to be plugged in here. So amount has to be in moles, and volume has to be in liters. And just like we studied when we came out of gas laws, that you might be given grams or asked for grams in an equation that involves the letter N, but you'll need to use molar mass to convert. So we'll leave that for a moment. But again, capital M is molarity. Sometimes you might also see molarity written with brackets. And then, if I was finding the molarity of salt, then it might be written like this, NaCl in brackets. That's saying what's the molarity of salt in this solution. So that's another way that you might see molarity written. When you have a value of molarity, let's say I have a solution and it's labeled 6M, 6 capital M, that is saying you would read that as 6 molar. So that's just a vocabulary thing of reading the terms. If it's, a capital M written after your number, 6 molar, and that means that there's 6 moles per 1 liter in that solution, because it is moles per liter are the units of molarity. So let's take a look at both parts of our molarity equation. We have moles of solute, so there's our N. This is the amount of dissolved particles, and you can use molar mass to convert between grams and moles if needed, just like we did for gas laws. Remember, molar mass is on the periodic table. Another note about the solute: if you add solute, then you're going to increase the molarity. So more of the particles dissolved, more concentration, which is the same as molarity. Liters of solvent, this is our V. That's our volume of the dissolving liquid. And this has to be in liters. So again, a helpful conversion we've used a lot is that there's 1,000 milliliters in 1 liter. If you need to convert between milliliters and liters, again, very similar to what we did with gas laws, it must be in liters, so convert as needed. If you are to add solvent, then this would decrease the molarity because you are diluting it. You're making that ratio between solute to solvent smaller because now you have more of the liquid but the same amount of solute, so it's going to be overall a smaller concentration or molarity value. So in a little example, if I were to have 3 different solutions, and one was 1 molar, one is 0.5 molar, and one is 5 molar, the most concentrated would be 5 molar because it has the largest amount of solute in the liter. This is saying there's 5 moles per liter. And the most diluted would be 0.5 because that's saying I have a half of a mole of solute per 1 liter. So the bit greater your number of molarity, the greater its concentration. And the smaller the number, the more diluted it is, or less it's concentrated. We have a few examples here. Again, just making sure our numbers are in moles and liters, and then we can divide to find the molarity. So the first one's pretty straightforward. Find the molarity of a solution made of 4.2 moles of our solute and 5.0 liters of our solvent. The solute is sodium nitrate and the solvent is water. So this one we're going to put our amount of moles on the top. Moles per liters. So there's our molarity calculation, and we plug these in and you'll get 0.84 molar. Or you could write this with the units moles / liters. These are the same. So whichever way you want to write it. And I also said you could put it in brackets, so this is also another way to show the concentration of NaNO3. What is the molarity of a solution made of 2.4 grams NaCl and 20 milliliters? So now we have, again, amount and volume, but they're not in the right units. So we'll need to convert our grams into moles and our milliliters into liters. Let's start with our grams. And this problem nicely gives us the molar mass. I think this whole unit gives you the molar mass. There might be one problem in the practice where you have to find it just as kind of a review, but we already have mastered that skill. So I have tried to save you some time by providing the molar mass. So there's our moles. And then 20 milliliters, if we divide that by 1,000, then we get 0.02 liters. So now I can put my molarity calculation in here. Moles over liters. And I get 2.05 molar. And again, you could label it as moles per liters. Those will be the most common ways you'll see it. Okay, and then the third example here is using our solubility curve, kind of what we did last week, to figure out how much solute will be dissolved. And then we're going to need to do kind of what we did in example 2, make sure our units are correct to plug in. So we'll need moles and we'll need liters. So let's identify our solute. What is the molarity of a saturated solution of KNO3 at 70 degrees in 100 grams of water? Our solute is potassium nitrate. So we're going to need moles of that. And then our solvent is water. We're going to need liters of that. Currently it's in grams. So let's start with the solute. Saturated means on the line from last week. And we need it to be at 70 degrees. So let's find here 70 degrees. Here's our KNO3 line. So we're going to find where those intersect right here. Okay, so our amount of solute is 140 grams of KNO3. And we're going to need to use this given molar mass. Which will give us, plug that in the calculator, 1.38 moles of potassium nitrate. And now all we have to do is find the liters. We know it's 100 grams, and this little conversion tells us a gram is a milliliter because the density of water is 1 gram per milliliter. So that's just a nice little conversion. So we can go ahead and just say that this is 100 milliliters. And if we use our divide by 1,000 conversion factor, we're going to get 0.1 liters of water for our solvent. So now we are ready to rock and roll with our molarity calculation. 1.38 moles, 0.1 liters. That gives us a molarity of 13.8 molar, or moles per liter. Remember, capital M means moles per liter. So our last question here says, which solution, 1, 2, or 3, is the most concentrated? So we've got 13.8 molar, 2.05 molar, and 0.84 molar, which is the most concentrated. It looks like we actually increased as we went from example 1 to example 2 to example 3. So the most concentrated would be example 3 with a molarity of 13.8 moles per liter. Example 3. Now you have some practice problems on page 4 following the same process. Molarity equals amount over volume, always plugging in moles and liters for your units of amount and volume. And then that will spit out moles per liter as your unit of molarity. And just like we've been saying over and over, capital M can be used for the unit. I know it's kind of different because we don't ever put, N as our unit for moles or V as our unit for volume, but for molarity, you can use them interchangeably as the unit as well as the variable. So in all of these, make sure you have moles and liters, plug them in. 3, 4, and 5 kind of break it down for you to convert to moles, and then convert, or I suppose calculate using moles and liters. Same thing. I think number 4 is the only one that doesn't give you a molar mass, so I'm going to give that to you now because it's not on here. And I mean, you can definitely check it if you'd like, or calculate it yourself. Make sure that it matches. But the molar mass of iron to chloride is 126.75. So you can use that to convert to moles. Okay? So that should have you all set for today. Tomorrow you're looking at a computer concept builder with concentration and some practice problems, again finding the molarity, determining the grams as needed using molar mass, and see they're all provided there for you to help you find molarity.